Now, I'm sure as you've learned in your experience as an IT professional that the easy way to accomplish something is not always very well aligned with the correct way to accomplish that thing. And it's for that reason why I kind of started with the very easy way in which you can just light up this RAS server and very quickly connect a client in. But this way, this mechanism, this protocol, if you will, of the client connecting here into the server is perhaps not the very best way in which that client could make the connection. If you take a look here at the list of remote access clients currently connected into this server, we can see that company G Shields on that machine is connected up, has been for about 4 minutes here. And if I take a look at the statistics here, there's just some basic data associated with that connection. So this gives me a feel for just who is connected up here into the server and what amount of data is being transferred back and forth. I can also over here under ports identify which protocol is being used for getting that client connected up here into this server. And it's here where we can kind of highlight some of the decisions that are made on the part of the RAS server in order to just simply get this client connected. RAS will, by default, try to use whatever protocol it can to get a client connected. You can limit that by turning off protocols. You can limit it further by not providing the requirements for those protocols. But as you can see here, there are a variety of different ways, different protocols that allow clients to connect, like SSTP, like PPTP, like L2TP, and then IKE-v2. Here in just a minute, I'll show you what the differences are between these protocols. But the one thing I want to make you aware of is that with this single client now currently connected to our RAS server, we can take a look at the status over here to identify exactly what port that client is connecting in on. So let me scroll up here and try to find the one where it goes from inactive to active right there. Notice how this client is connecting in over PPTP port 127. And if I look at the status, I can confirm that indeed that's the IP address for that machine. This is great because I'm connected in, but PPTP is the oldest and least secured of all the ones that are available. And so whereas the client is indeed connecting in, it's actually connecting in via not a really great connection. So let's talk about some of the different ways in which we can lay these requirements in place to elevate the security level of the incoming clients as they come in. I want to start by directing your attention over here to the server itself, where we can take a look under Properties at the Security tab here. And there's a couple of items here that we don't really care about for now, which I'll skip over, and even some of the tabs here, which you won't see here at this point. But what I do want to point your attention to is here for the Authentication Provider, where we can identify what the authentication methods will be used in order to figure out who this client is and get it connected up here into this server. For the provider, we can choose Windows Authentication or Radius. We're not using an NPS server, so we won't use Radius at this point. We will a little later. But for the authentication methods, it's here where we can identify which of the possible methods this RAS server will attempt to use to connect this client in. Now you can see there are a variety of different methods here, and in fact what I want to show you is a little cheat sheet here that will help you understand what all these possible authentication methods are, what they provide, and in some cases what they don't provide. So this little cheat sheet here talks about all the different methods we saw just a second ago, the first of which is EAP-TLS, which is one of the stronger methods that exists because it can be used with smart cards, it can be used with digital certificates. However, EAP-TLS can only be used when your RAS server is configured for Radius authentication, or if the RAS server is domain joined. So you get all the nice benefits of EAP-TLS and the pretty good high security of EAP-TLS, but only when that RAS server is part of your domain or when it's plugged into a Radius server on the inside in order to provide that authentication for it. Now that's not always something that you can accomplish, so these other authentication methods also exist. MS-CHAP v2 can provide mutual authentication. It also provides for encryption of both the authentication process as well as the session data as that person interacts with your server and the resources inside. So MS-CHAP v2 provides for that greater level of authentication, that higher level of security, but doesn't provide for the smart cards and other sorts of advanced authentication things that you get with EAP-TLS. Contrast this with CHAP, where authentication is encrypted via a much older MD5 approach for hashing the data as it's coming in, and where the session data, not just the authentication, the initial authentication, but also just the session data throughout the course of that user working with their resources, that session data will not be encrypted using CHAP. SPAP is even less of a secure protocol because it's intended only for use in down-level support. SPAP uses a basic quote-unquote encryption for authentication only that can be trivially decrypted via a variety of automated techniques. Essentially, if a person sniffs enough traffic, they'll be able to decrypt the information that goes from client to server. If you look through the documentation, SPAP is there, but it's highly not recommended for use. Same thing for PAP. PAP doesn't provide any kind of encryption at all for either authentication or for session data. And so when you're using PAP, you're transmitting those passwords in the clear, and anybody that happens to be watching that communication could potentially get a person's username and password. Now, the last of these is not any less in terms of security. It's in fact perhaps even a little better, because machine certificate authentication provides a way for you to use pre-installed digital certificates that correspond with machines as opposed to users. Now, the certificates have to exist both on the server for server authentication, as well as on each connecting client for client authentication. That server has to have a server authentication enhanced key usage property set on the cert that's installed onto your RAS server. Your clients also have to have a client authentication certificate on their machines stored in local computer/personal. So if you do want to go down the path of machine certificates as your basis for authentication, as opposed to or in addition to user authentication, this provides another step that ensures that not only is the user allowed to connect, but also the machine as well. However, in order to do that, you do have to distribute around certificates using some PKI or other mechanism, which can be a bit of an administrative overhead. So these are the different kinds of authentication methods that you'll see as we're looking through the screen that we saw just a second ago. Notice how by default, some of these authentication methods are made available, whereas others are not. So EAP, for example, MS-CHAP v2, and CHAP are all available as possible authentication methods for clients that are coming in. And so based on what you want to set as your basic minimum level of security, you could enable or disable these different authentication mechanisms here to provide or not provide them for the clients coming in.